In this video, we're going to be solving for unknown sides in a right triangle by using some trig functions. All right, to start off with, hopefully you know this acronym SOHCAHTOA. What it helps us understand is which two sides in our right triangle correspond with each of our trig functions. For example, tangent, or TOA here. The O and the A stand for the opposite and adjacent sides. So tangent function uses opposite and adjacent sides. Sine, or SO here, SO is reminding us that the sine function uses opposite and hypotenuse sides. And then the last thing, CA, C for cosine, A for adjacent, H for hypotenuse. So this part of our acronym is reminding us that the cosine function uses adjacent and hypotenuse sides in its ratio. All right, so these are the equations that we are going to be using. Hopefully you're familiar with these ratios. We're going to be identifying the parts of our triangle and labeling them with those words. And then we'll use that to determine which of these three trig functions we're going to use. And then we'll use its equation here to solve for an unknown side length. Here's our first example. This is our reference angle here. We're going to use that. Relative to that angle position, the side across from it is going to be labeled the opposite side, and the side next to it is going to be labeled the adjacent side. If you're thinking that, well, there are two sides that are next to that angle, this side is across from the right angle, and that side that's across from the right angle is always called the hypotenuse. It's never called the adjacent side. So you could think that the adjacent side is touching your angle, but it's not the hypotenuse. So since we have the opposite and the adjacent side, that should remind us that we're going to use the tangent function here. So we'll set up that equation. We're going to say tan of 27 equals our opposite side over our adjacent side, x over 20. To solve for x, we need to undo this division of 20, so we're going to multiply both sides by 20. That's going to cancel this side, leave us with x. That's what we want. And so x must be whatever 20 times the tangent of 27 is. And at this point, this is just calculator button pushing. Type in your calculator 20 times tan of 27, and it should give you a decimal that says 10.19 something, 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 something. We're going to round to the 10th spot here. So that's our first decimal place. We look to the right. Values of 5 or higher are going to make us round this up, so we're going to round up to 10.2. In this next example, again, using our angle that's given to us as our reference angle. From that position, this side across from it will be opposite. This side next to it, that's not the hypotenuse, will be the adjacent side. Because I am using those two pieces in my problem here, I know the opposite and adjacent goes with tangent. So once again, we're going to set up the tangent equation. Say tan of our angle equals our opposite side length over our adjacent side length. This time, notice that the missing or unknown length is in the denominator, whereas in our last problem it was in the numerator. We're going to use slightly different algebra here. To undo this division of x, or to get our x out of the denominator position, we're going to multiply both sides by x. That'll cancel it on the right side, but leave this product on the left side. X times tan of 55 equals 11. So now to undo our product here, or undo the multiplication, we're going to use division. We're going to divide by our tangent function. And so our x value is now going to be whatever 11 divided by the tan of 55 is. So again, at this step, this is just button pushing on your calculator. Type in 11 divided by tan of 55, and you should get approximately 7.7. All right, I want to emphasize some patterns that happen every time we use a trig equation here. Again, if we are solving for the numerator, notice that it was a multiplication step. And then over here, when we were solving for the denominator, it turned into a division step there. So as you get more and more comfortable solving these equations, you might be able to jump to that shortcut right there. Instead of writing your equation and using algebra steps, you might be able to notice that, well, I'm solving for the numerator, so I'm just going to multiply the side length given to me by my trig function. Or over here, if I am solving for the length in the denominator position, I'm going to take my side length that was given to me and divide by my trig function. I'll keep pointing that out in some future examples here. All right, next example. Again, given this angle as our reference angle, relative to its position, this side length is across from it, so this is our opposite side. This side length is across from the right angle, so we're going to call this one the hypotenuse every time. Seeing that we have opposite and hypotenuse, hopefully that reminds you that we're going to use the sine function and use that equation. Notice that the equations are all the same. All that changes is our trig name. And all the algebra steps are all the same as well. So we'll set it up. Sine of our angle this time is equal to opposite length over hypotenuse length. To undo this division, we're going to multiply by 17. And so because we're solving for the numerator, notice that we're just taking the side length that was given to us and multiplying by our trig function here. Doing that on your calculator, you get about 14.09 something something something. We're going to round that up to 14.1. Similar example over here. Recognize that given this angle relative to its position, we're once again provided an opposite side length, but this time we're asked to solve for the hypotenuse side. So when we set up our equation, sine goes with opposite and hypotenuse, so we're going to use sine of our angle measure equals the opposite side length over the hypotenuse. Now that we're solving for the denominator, eventually, hopefully you're good enough to say, well, it's just going to be that side length divided by my trig function. But if you're not quite there, let's do our algebra steps again. We want to get that x out of the denominator position, so we'll multiply both sides by x, canceling it on the right side, but now creating a product here on the left side. We'll undo that multiplication by dividing by our sine of 50 to get x by itself, and so that turns into 19 divided by the sine of 50. Using your calculator, typing that in, it should tell you it's about 24.8. All right, two more examples here. This time, given the angle of 56 degrees relative to its position here, we have the adjacent side, the side next to it, and we have the side across from the right angle. That's always the hypotenuse. So adjacent and hypotenuse remind us that we're going to use a cosine equation. So we'll set it up. Cosine of 56 equals 18 over x. We want the adjacent side over the hypotenuse. Because we're solving for the denominator, take that side length and divide by your trig function. Or follow the algebra steps, and eventually you'll end up there anyways. Using your calculator, it should tell you it's about 32.18 and continues, so we're going to round that up to 32.2. Last example here, let's see how it's similar to the last one. One last time, given this angle relative to its position, we are asked for the adjacent side given the hypotenuse side. So adjacent and hypotenuse means that we're going to use cosine when we're solving. Let's set up our cosine equation. Cosine of the angle equals the adjacent side divided by the hypotenuse. This time we're solving for the numerator, so we're just going to take our side length and multiply it by our trig function. So 11 times the cosine of 51 on your calculator tells you it's about 6.9. All right, so let's review those three steps. We're always trying to identify the pieces that are provided in the problem and labeling them using the words opposite, adjacent, or hypotenuse. Once you've established the parts that you have, remind yourself what trig function goes with those two pieces. and then use that equation and your algebra steps to get to your solution. Practice solving for unknown sides and right triangles. And next time, we're going to be solving for unknown angle measures, still using the exact same ratios defined right here.